A lot of the world, when they make measurements, utilize the metric system as opposed to the imperial system, which we use in the United States. And the reason that the metric system is preferred is because it's base 10. So that means that all the conversions between your different metric units are based on the number 10 or some factor of it, some power of it, 100, 1,000, 10,000, 100,000, things like that. As opposed to the English system where, say, take for instance volume. You have 8 fluid ounces to a cup, 2 cups to a pint, 2 pints to a quart, 4 quarts in a gallon. We have 12 inches in a foot, 3 feet in 1 yard, 5,280 feet in 1 mile. All of those conversions are different numbers. But with the metric system, it's all based on the number 10 and some factor of it. So we can use a conversion factor just as we can in the imperial system, and we have to, in order to be able to convert a quantity from one unit of measure to another. But with the metric system, there can be an even easier way, and that is just by moving a decimal point, which can be far easier than dealing with all those conversion factors. We'll take a look at both ways. If we take a look at a number line with the metric scale, we can see that each step, each unit, represents a different power of 10. And so starting at the middle would be just your plain old base unit. So if we're talking length, that would be meter. If we're talking mass, it would be grams. If we're talking volume, it would be the liter. And all of your metric units are going to be generally a 2-letter symbol. The first letter is going to be these metric prefixes that you see on the number line in front of you. The second letter will be that base value, that base unit. And again, that's going to be determined on the type of quantity that you're dealing with. Are you talking about a mass, a volume, or a length? If we take a look at the higher end, if we talk about 10 to the first power, which would be just 10, then the prefix for that is deca. And this is one where you might see some variation in the symbol that's used. Either a capital D or some sources use a lowercase da. 10 to the second or 100 would be hecto or H. And then probably the most familiar of these three is kilo, which would be 10 to the third power or 1,000 with a lowercase k as your prefix. On the opposite end, and it should be noted that this center section here is probably the most familiar section or the most commonly encountered metric prefixes. But as we'll talk about with the further extremes, we might have occasion to interact with those. Going smaller than one whole unit, we go to 10 to the minus 1, which would be 1/10, and this is deci, lowercase d for the symbol. 10 to the minus 2 power would be 1/100th, or centa. So a centimeter is 1/100th of a meter. And then finally 10 to the minus 3, which would be 1/1000th, and that's milli with the lowercase m. So when you see, for instance, just a single m, lowercase m, that's a meter. That's your base unit for length. If you see mm, both lowercase, that's a millimeter, 1/1000th of a meter. So you have to pay attention to what's the letter, but also how many letters are there and what's the order of them. If we go on the larger end of the spectrum, we see that we jump 3 powers of 10 to 10 to the 6th, which would be million, and the prefix for this is mega, capital M this time. We go 3 more powers of 10 above that to giga, that's 1 billion, or 10 to the 9th power. And we go still another factor of 1,000 higher than that, 10 to the 12th power, and we see the prefix tera, capital T, for a symbol here. These prefixes are probably most notably experienced when we're talking about computers, hard drive capacities, memory capacities, things of that nature. If we go on the smaller end of the spectrum, so now we're back down, remember milli was 10 to the minus 3rd, if we go 1,000 powers or 1,000 times smaller than milli, we get micro, which is 10 to the minus 6th, 1/1,000,000th. Now the prefix for micro is the Greek letter mu. Kind of looks like a lowercase u with a tail on the front end of it. We go another power of 1,000 smaller than that. We get 10 to the minus 9th, which is 1/1,000,000,000th. And now we get into nano, or lowercase n. So when you hear about nanoscience and nanotechnology, you're talking about things, materials, devices that are on the nano scale, which is about a billionth of a meter in size. We go even smaller than that, down to 10 to the minus 12th, which would be 1 trillionth. And here the prefix is pico with a lowercase p for your symbol. And so, as we talked about, there are a couple of different ways that we can convert between these units. One is to use conversion factors, but if you simply use this number line approach, you can get an idea of what the powers of 10 are, and how many powers of 10 difference you have between your units is going to correspond to how many decimal places you need to move your decimal point. In terms of which direction do you go, you can use the number line to help you with that as well. But you can also remember that when you convert from a large unit to a smaller unit, you're going to move your decimal point to the right. When you're converting from a smaller unit to a larger unit, you're going to move your decimal point to the left. If we use our conversion factors, any conversion factor is going to take two equivalent quantities and put them in a ratio format. And we set the ratio up so that the units that we want to get rid of will factor out, and the units that we want to keep will stay behind. So if we want to convert 250 milliliters into liters, we start by writing down our original value, and then we set up our conversion factor. Now, there are 1,000 milliliters in 1 liter. So if we want to cancel the milliliters out, we need to put them on the bottom, right? Okay, so the milliliters will cancel, leave us with liters in the numerator, and when we do the math, you should come up with an answer of 0.250 liters. If we take 1.42 kilograms and we want to convert that into micrograms, all right, 1.42 kilograms, we start by writing that down, and then we know that micro is 10 to the minus 6th power. Kilo is 10 to the positive 3rd power. So there's actually 9 powers of 10 difference from micro to kilo. And so when we set up the conversion factor, we want the kilograms to be on the bottom so that we can cancel them out. But we would have 10 to the 9th or 1 billion micrograms per 1 kilogram. Right? Notice that the conversion factor we're using is relative to those two units, and the numbers that we use are relative to those two, but they are expressing equivalent quantities. So we would factor the kilograms out, and this sort of answer would probably be best to keep in scientific notation, so it makes it very easy, and we would get for a final answer 1.42 times 10 to the 9th micrograms.
Because the metric system is base 10, it means that converting from one unit to another is extremely easy. It's as simple as moving your decimal point one direction or the other a certain number of places. How many places you need to move it is going to depend upon the powers of 10 represented by the units themselves. So in this first example, we have 250 milliliters. We want to convert it to liters. Now milli is 10 to the negative 3rd level. It's 1/1000th. And liters is a base unit. So base units correspond to 10 to the 0 power, or just 1. So we can see there's 3 powers of 10 difference between the units that we want to convert in between. And so now the question remains, which direction should we move our decimal point 3 places? And if you think about it, when you have equivalent amounts, if you've got a smaller unit, you're going to need more, quantitatively more of that smaller unit to equal a certain amount of a single larger unit. So if we've got 250 milliliters, the numerical equivalent in liters is going to be a smaller number. So whenever you're going from a small unit to a larger unit, you're going to move your decimal point to the left. So in this case, we're going to take that decimal point, we're going to move it 3 places to the left, and our answer would be 0.250 liters. All right. Now in terms of significant figures, with that decimal point showing in the original value, that means that that trailing 0 is considered significant. And just by changing the way you express a measurement doesn't change the significance or the number of measured digits that you can report. So we would want to leave this last 0 present in our liter expression of the volume, because it is still considered significant and represents a measured value. All right, 12.52 centimeters to millimeters, centa, represents 1/100th or 10 to the minus 2 power. Milli is 1,000th again, So that's 10 to the minus third power. So here we only have 1 power of 10 difference. And in this case, we're going from a larger unit, centimeters, to a smaller unit, millimeters. And so this time, the decimal point is going to have to move in the opposite direction. Larger unit to a smaller unit, you move your decimal to the right. Because it's only 1 power of 10 difference, we're going to shift it one place over, and therefore 12.52 centimeters in millimeters would be equivalent to 125.2 millimeters. Our final example here is to take 4,895 grams and convert them to kilograms. Grams is a base unit, so it's equivalent to 10 to the 0 power. Kilograms, the prefix kilo, it means 1,000, or 10 to the positive third power, so 3 powers of 10 difference. We're going from a smaller unit to a larger unit, so we need to take that decimal point and we're going to move it 3 places to the left, and our answer would be 4.895 kilograms.